Hello, my name is Daniel, and today we will be going through the AMC 12B from the year 2013. So let's get started. First problem. On a particular January day, the high temperature in Lincoln, Nebraska was 16 degrees higher than the low temperature, and the average of the high and low temperatures was 3. In degrees, what was the low temperature in Lincoln that day? Okay, so since it was 16 degrees higher, that means, so this is the difference between the high and low temperature, so that means the high was 8 up from the average, and the low was 8 down from the average, and we want the low temperature, so it's 8 down from the average, so it's 3 minus 8, which is minus 5, and that's our answer, it's C. Number 2, Mr. Green measures his rectangular garden by walking 2 of the sides and finds that is 15 steps by 20 steps. Each of Mr. Green's steps is 2 feet long. Mr. Green expects half a pound of potatoes per square foot from his garden. How many pounds of potatoes does Mr. Green expect from his garden? Okay, so since his garden is 15 by 20 steps, which is just basically 30 by 40 feet, since each step is 2 feet long, and each square foot is half a pound, so times 1 over 2, this gives us 600. So that's our answer, it's A. Number 3, when counting from 3 to 201, 53 is the 51st number counted. When counting backwards from 201 to 3, 53 is the nth number counted. What is n? Okay, so since 53 is the 51st number counted, this number comes because of its 53 minus 3 plus 1. This 3 is because we start from 3. And same thing here, we count backwards from 201 to 3, and we want the nth number when it's 53. So this is going to be 201 minus 53 plus 1, which is 202 minus 53 equals 149, and that's our answer, it's D. Number 4, Ray's car averages 40 miles per gallon of gasoline, and Tom's car averages 10 miles per gallon of gasoline. Ray and Tom each drive the same number of miles. What's the car's combined rate of miles per gallon of gasoline? Okay, so let's say that they each drove 40 miles. Then in total, they will have spent, Ray would have spent 1 gallon, and Tom would have spent 4 gallons, right? So that it's going to be 5 gallons total. And since both cars drove 40 miles, then that means the total distance is going to be 80 miles total. And so if we divide this, then we get 16 miles per gallon. So that's our answer, it's B. Number 5, the average age of 33 fifth graders is 11. The average age of 55 of their parents is 33. What is the average age of all of these parents and fifth graders? Okay, so this is going to be 33 plus 55 people, so that's 88 people. 8 times 11, and then these two multiplied plus these two multiplied, that's going to be 3 times 11 squared plus, and then these two multiplied, so it's 15 times 11 squared. That's going to be equal to 3 plus 15, which is 18 times 11 over 8. So this is going to be 9 times 11 over 4, right? So it's 9 times 11 over 4, which is 99 over 4, which is 24, and 3 over 4, which is 24.75, right? 24.75. So that's our answer. It's C. Number 6, real numbers x and y satisfy the equation that this is true. What is x plus y? Okay, so just moving these over there, that gives us that x squared minus 10x plus y squared plus 6y plus 34, right? 34 equals 0. That gives us that x minus 5 squared plus y plus 3 squared. 3 squared. This is going to be equal to 0. This gives us that x equals 5 and y equals negative 3. If we add them together, then their sum is 2. And that's our answer, it's B. Number 7, Joe and Blair take turns counting from 1 to 1 more than the last number said by the other person. Joe starts by saying 1, so Blair follows by saying 1, 2, and then 1, 2, 3, and so on. What is the 53rd number said? Okay, so the number of numbers said, this is going to be 1, and then 2 numbers, and then 3 numbers are going to be said, and so on. So that's going to be 1, 2, 3, so on, right? And we want the 53rd number said. And we know that the sum of 1 to 10 is 55, right? So the 55th number said is going to be 10. So the 55th number is going to be 10, so 54th is going to be 9, and the 53rd is going to be 8. So that's our answer. It's 8. It's E. Problem number 8. Line L1 has equation 3x minus 2y equals 1 and goes through A equals negative 1, negative 2. Line L2 has equation y equals 1 and meets line L1 at point B. Line L3 has positive slope, goes through point A and meets L2 at point C. The area of triangle ABC is 3. What is the slope of L3? Okay, so if we have a grid here like that, right, and then let's say that our axes there, this is, that's going to be the y-axis. So this is the y-axis, and the x-axis, let's say that's right over here. So that's our x-axis, and we are going to have this one, so that line is going to look something like, it's going to go from here, so from A, and then like that. Yeah, and L2, that has y equals 1, so that's just this thing, right? Yeah, that's this one. And that's, yeah, and this is point B. So this is point B, and this is point A. And then line L3 has positive slope, goes through point A and meets L2 at point C. And so that line is going to look something like it goes from A, and then since its area is 3, it's going to go like that, right? Because if you look at this triangle, then this is the base and this is the height, and so that will mean that, yeah, for the area to be 3, that means this times this should be 2 times 3, which is 6. That's why this length is 2. And where's the slope of L3? It's just rise over run, 3 over 4, 3 over 4. That's our answer. It's B. Number 9. What is the sum of the exponents of the prime factors of the square root of the largest perfect square that divides 12 factorial? Okay, so we know that 12 factorial equals, if we do our how to find the prime factors of the square root, that's going to be 2, 3, 4, 5, 6, 7, 8, and 9, and 10, and 11, and 12. Like that, right? So this is going to give us 2 to the 10th power, and then 5 threes, so that's going to be 3 to the 5th power times 5 squared times 7, yeah, times 7 times 11. And then the square root of that, so yeah, so the largest square root of that, so that's going to be 2 to the 5th power times 3 to the 2nd power times 5 to the 1st power. And we want the sum of the exponents, right? So that's going to be 5 plus 2 plus 1, 5 plus 2 plus 1 equals 8, and that's our answer. It's C. Number 10. Alex has 75 red tokens and 75 blue tokens. There is a booth where Alex can give 2 red tokens and receive in return a silver token and a blue token, and another booth where Alex can give 3 blue tokens and receive in return a silver token and a red token. Alex continues to exchange tokens until no more exchanges are possible. How many silver tokens will Alex have at the end? Okay, so we have red, blue, and silver. We have 75, so Alex has 75 and 75 at the start. And since Alex can give 3 blue tokens and receive 1 silver token and a red token, that means if we use up all the 75, then this is going to be left to 0, and this is going to be 100 red and 25 silver, right? And if we use all of those red, then that's going to give us no more red, and 50 blues, and 75 silver, right? Because we added 50 more. And same thing, use as much of the blues as we can. That's going to give us 2 left, and that's going to increase both by 16, so this is 16, and this is going to be 91, right? And then use this as much as possible. That's going to give 0, and then that's going to make this 10 blues, and 8 more, so that's 99. And lastly, not lastly, we use as much of that as we can. We get 1 and 3, and that's just adding 3 more, so it's 102. And finally, using that, we just get 1. Yeah, we get 1, and then 103. So this is our final answer because we can't do anything else with that. So it's E. Number 11. 2 bees start at the same spot and fly at the same rate in the following directions. BA travels 1 foot north, then 1 foot east, then 1 foot upwards, then continues to repeat this pattern. BB travels 1 foot south, then 1 foot west, then continues to repeat this pattern. In what directions are the bees traveling when they are exactly 10 feet away from each other? Okay, so let's say that they begin at 0, 0, 0. Since this has north and east and like up down, that means we need to go in the 3-dimensional plane. So let's say they begin at 0, 0, 0. And then since BA, one cycle is just, yes, so one cycle consists of 3 steps, and BB, one cycle consists of 2 steps. So let's consider the case where it's 6 steps. 6 steps later. And that means A is going to be at 2, 2, 2. And then B is going to be at -3, -3, 0, right? Because B doesn't go up or down. And so if we get the distance, right, then the distance is root, and then 5 plus 5, so 5 squared, 5 squared, 5 squared plus 4. That's going to be equal to root 54, so it's not 10 yet, so we need to go more. Let's say they went 7 steps. That's going to be equal to A is going to be at 2, 3, 2. B is going to be at -3, -4, 0. And that's going to give us distance of root 25 and then 7 squared. So it's 49 plus 4. This is root 78. This is still less than 10, so let's go one more. 8 steps. That's going to give us A is going to be at 3, 3, 2, and B is going to be at -4, -4, 0. And this distance is going to give us root 49 plus 49 plus 4, which is equal to root 102. That's when the bees are more than 10 feet away from each other. And so when they are exactly 10 feet away, then they must be in the middle of this. So in the middle of step 7 and 8, that's going to be when A is going east and B is going west. And so that is our answer, A east, B west. It's A. Number 12, cities A, B, C, D, and E are connected by roads A, B, A, D, A, E, B, C, B, D, C, D, and D, E. How many different routes are there from A to B that use each route exactly once, and it will necessarily visit some cities more than others, obviously. Okay, so first thing that we have to notice is that we don't need E and C at all, because if we're like going from D and then to E, then that means just only one more possible outcome, and that's just going to A, right? So having this E on the board is just the same as having some random city F on here and just going DF to FA like that, right? Or like AF to FD like that, right? We can just rule out those things and then just say that we are dealing with something that looks like this. So it's a triangle DAB, and there's two ways from A and B to D, right? So there's two ways each like that. And so here we can see that we can go from, starting from A, right? Because we always have to start from A. So it's going from A to, and then it can either go to D or go to B. So first let's consider when it goes to D, A to D. If it goes from A to D, then it can either go to B or to A, right? So let's just list out the cases. The cases where it goes like ADB, and then it can go like that, right? So that's gonna be ADB, BD, AB, like that. Or it could go like AD and then come back and then go like that, right? So that would be ADA and then BDB, like that. So it's ADA, BDB. And then, or we could go and then ADB and then just BAB like that, right? So that could happen. So that would be ADB and then ADB. And then now let's consider when we're going directly to B, right? And so that can be when it's going from that, and then that's only one thing possible left now. It's just like that. So that will be ABD, ADB. That will be ABD, ADB. And notice that for each of these four cases, we can choose which ones, we can choose which routes to take from going between D and B, and we can choose which routes to take between going A and D. So those are going to give 4 choices for each of these. So that's going to give 4, 4, 4, 4. This gives us a total of 16, and that's our answer. It's D. Number 13, the internal angles of quadrilateral ABCD form an arithmetic progression. Triangles ABD and DCB are similar, with DBA equals DCB and ADB equals CBD. Moreover, the angles in each of these two triangles also form an arithmetic progression. In degrees, where's the largest possible sum of the two largest angles of ABCD? Okay, so let's draw out this diagram here. This is going to be what it looks like, and if we say it's like A, and then B, and then C, and then D like that, and then that line is separating ABD and DCB, right? And so if we say that this angle is A and this angle is B, that would mean this angle is A and this angle is B, right? And now, since the angles of quadrilateral ABCD has to form an arithmetic progression, we can find that if we put in for this angle, if we put in half A plus B, half A plus B, and half A plus B, then that will give us a sequence of first B. So that will give us a sequence of first B, and then this one, half A plus B, half A plus B, and we can go this one, A plus B, so that's 2 over 2A plus B, and lastly this one, 3 over 2, so it's 3 over 2A plus B, right? So this is an arithmetic progression because it increases by half A each time. So this makes sense. And now have to see that those angles form arithmetic progression as well. So that's going to look like BA and then half A plus B, although it doesn't look like B is D smaller than A. So we can see that these, those and those distances are going to be the same. So A minus B, that and B minus half A is going to be equal, right? So that gives us that this is equal, so 3A equals 4B, right? And so now, since the sum of the internal angles is 180 degrees, that means 3A over 2 plus 2B, plus 2B equals 180, and A equals 60 degrees, and B equals 45 degrees. B equals 45 degrees, that's what we get. So this gives us that the largest possible sum of the two largest angles is that the two largest angles, this one and this one, right? It's A plus B plus half A plus, 3 over 2A plus B, right? So this is going to be A plus B plus 3 over 2A plus B. This is going to be 5 over 2A plus 2B. And if we plug those in, then this is going to be equal to 150 plus 90, that is 240 degrees, right? So 240 is the answer, it's D. Number 14. Two non-decreasing sequences of non-negative integers have different first terms. Each sequence has the property that each term beginning with the third is the sum of the previous two terms, and the seventh term of each sequence is n, where is the smallest possible value of n. Okay, so if those sequences start with a and b, and then the other sequence starts with c and d, we can see that if we keep on going from a and b, then it's going to be a plus b, and then it's a plus 2b, and then 2a plus 3b, and then 3a plus 5b, 5a plus 8b, right? That's 5a plus 8b. Now this is going to be our seventh term. For this to go on, that's going to go in exactly the same way. So this is going to end up at 5c plus 8d. And so we have to see that 5a plus 8b equals 5c plus 8d. So 5a plus 8b equals 5c plus 8d. Yeah, so here it's when 5 plus 8, it's 13. This should be 13 times 8. And so if that happens, then it can be that a and b are 8, c is 0, and d is 13. These both give us the answer of 13 times 8. So that's the smallest possible value of n. It's 13 times 8, which equals 104. And that's our answer. It's C. Number 15, the number 2013 is expressed in the form 2013 equals this thing, where a1, a2, all the way to am, yeah, so it's in decreasing order, and b1, b2, same thing, b1 is the greatest, and then it's all decreasing like that, right? And they're positive integers, and a1 plus b1 is as small as possible. What is the absolute value of a1 minus b1? Okay, so if we factorize 2013, this is going to be 3 times 671, and 671, that is 61 times 11, right? So it's 3 times 61 times 11. So those are the prime factors. So it's going to be 61 factorial over 60 factorial times 11 factorial, 11 factorial over 10 factorial times 3 factorial over 2 factorial, right? That's how it gives us 61, 11, and 3. But then notice that the 60, that is, we can just make it 59 factorial and then just get 60 here, 60 like that. And we can split up 60 into like these different things, and so that will give us that this is 61, this is 59. Those are the minimum values of a1 plus b1. So this gives us that this is going to equal 61 minus 59. Absolute value is 2. So there's our answer. It's 2. It's B. Problem number 16. Let ABCDE be an equiangular convex pentagon of perimeter 1. The pairwise interactions of the lines that extend the sides of the pentagon determine a 5-pointed star polygon. Let S be the perimeter of the star. What is the difference between the maximum and minimum possible values of S? If we draw out one of these stars, right, then it's going to look something like that. We can look at the center pentagon, and that also has to have equiangular. So this is going to be 108 degrees also. And that means that this is all going to be 72 degrees, so this must be 72 degrees. Therefore, this must also be 36 degrees. That means all of the triangles, right? So all of the triangles that stick out like that, right? So all of those triangles are isosceles triangles. And since they are 36, 72, 72 like that, that means if we have 36 and then 72 and then 72 like that, if we bisect that angle, then this is also going to be 72, and this is also going to be 36. And so if we have like 1 and then A, and then this will be also A, right? Because we see that this is isosceles, because this is 36 and this is also 36. So this and this is equal, and this is equal, so we get that's A. And so this to this ratio equals this to this ratio. That means A over 1 equals 1 plus a over a. So that gives us a squared equals a plus 1. And so a squared minus a minus 1 equals 0. From here we know that a is a fixed value. And the maximum and the minimum possible values of s, this means that s is also fixed. So s is constant, so the maximum equals the minimum. That means the difference is 0. It's a. Number 17. Let A, B, and C be real numbers such that this and this, they are true. What is the difference between the maximum and minimum possible values of C? Okay, so maybe this time we have an actual maximum and an actual minimum. Okay, so first of all, let's try to visualize A and B as x and y. So this gives us that a plus b equals 2 minus c, and this one, that gives us that a squared plus b squared equals 12 minus c squared. So that thing, if we look at a plus b as x plus y, that means that x plus y equals 2 minus c, and y is going to be minus x plus 2 minus c. And so that's going to look something like, if we have it like this, then that's going to be, we have a line like that, and then like that. This is going to be 2 minus c and 2 minus c. So that's going to be this line, And for this, we see that this is x squared plus y squared equals 12 minus c squared. So this is basically a circle centered at the origin with a radius of root 12 minus c squared. And so that's going to give us a circle like that, and that's going to be like that. And we know that this one, so that length is going to be root 12 minus c squared, right? But then for that to be true, this must be 90 degrees, and so since that has a slope of -1, that means this is 45 degrees. And so what that means is that 2 minus c is root 2 times root 12 minus c squared. If we square both of these, square both sides, that gives us c squared minus 4c plus 4 equals 24 minus 2c squared. So this gives us that 3c squared minus 4c minus 20 equals 0. So this gives us the c equals, so if we solve for c, then that gives us 10 and 3 and 1 and 2, and that's the minus. So this gives us that c equals 10 over 3, right? C equals 10 over 3, or minus 2. So the difference between the maximum and minimum c is the difference between these two. So that's going to be 10 over 3 plus 2, that's going to be equal to 16 over 3, and that's our answer. It's D. Number 18. Barbara and Jenna play the following game in which they take turns. A number of coins lie on a table. When it's Barbara's turn, she must remove 2 or 4 coins unless only 1 coin remains, in which case she loses her turn. When it's Jenna's turn, she must remove 1 or 3 coins. A coin flip determines who goes first. Whoever removes the last coin wins the game. Assume both players use their best strategy. Who will win when the game starts with 2013 coins and when the game starts with 2014 coins? Okay, so the only way to go about this problem is just to try out multiple values of the number of coins, and we will hopefully see a pattern. So if we have one coin, then that means Jenna must win, because if the coin flip lands for Jenna, that means just Jenna wins. And if it's Barbara, then she cannot remove any coins because only 1 coin remains, so she loses her turn, and automatically Jenna wins. And if it's 2 coins, then if it lands on Barbara first, then it's Barbara gets everything. If it's Jenna, right, then Jenna takes 1, and Barbara can't take anything, and Jenna can't take 1, so that's Jenna's win. So that's whoever goes first. And if we have 3 coins, if it's Jenna, then she just takes all of them. If it's Barbara, she must take 2, and so it's 1 left, so it's Jenna's turn. That means Jenna takes it all, so that's Jenna. And if it's 4 coins, we can see that if it's Barbara, then she takes 4 coins, but if it's Jenna, then she takes 3 coins, so it's 1 coin, so Barbara can't take anything. Therefore, Jenna will take the last coin, so it's always going to be the person who is going first. And until here, you might see, oh, it's Jenna first, like that. Jenna for odd, and first for even, and that's why Jenna will win with 2013 coins, and whoever goes first will win with the 2014 coins, because this is odd and this is even. And this is even. So for that, the answer is right, but the how you solved it, that's wrong. It's because if you try one more, try 5 coins, then it becomes weird, because if Barbara goes first, she must take out 2 or 4 coins, and whichever one she does, then Jenna removes the last few coins, and so Jenna wins. But if Jenna goes first, then whatever she removes, and whatever's left, Barbara can take all of them. So this is just the second person. So the second person is going to win here. So this pattern is going to keep repeating. So Jenna first, and second. So this is going to repeat. And if we keep going, that means the 2013th, that's going to be Jenna. Because 2013 mod 5 is 3, so this is for 2013. And the 2014th, that's this one. So that's going to be the first person. So that's why it's B. But then if you just saw these 4 and just went with B, that's also correct. Number 19. In triangle ABC, AB equals 13, BC equals 14, and CA equals 15. Distinct points D, E, and F lie on segments BC, CA, and DE respectively, such that AD and BC are perpendicular, DE and AC are perpendicular, and AF and BF are perpendicular. The length of segment DF can be written as m over n, where m and n are relatively prime positive integers, whereas m plus n. Okay, so first if we pull out a diagram here, that's going to look something like that. So let's say this is A, B, and C. Then BC is 14, and AB is 13, and CA is 15, and DE and F lie on BC, CA, and DE respectively, such that AD and BC, so these are right angle, and AF and BF are right angles. So this is F, that's a right angle, and DE and AC are right angle. So this is E, and that's a right angle like that. Okay, so first thing that we can see here is we can notice these two. So whenever 13, 14, 15 triangles come out on the AMC, always try to bisect it into 5 and 9, because that always works if you do this right triangle, and this is always going to be 12, because this 13, 5, 12, that's a Pythagorean triple, and this 9, 12, 15, that's also a Pythagorean triple. And so automatically we know that BD is 5, and DC is 9, and AD is 12. And so now we know that this triangle, that is a 30, 60, 90, sorry, that's a 3 to 4 to 5 triangle, because it's 3 to 4 to 5, and this one is similar to this triangle. And so this triangle, that's also a 3 to 4 to 5 triangle. And so that way we can get EC and DE. So if we get EC, this is going to be 9 times the cosine of that, which is 3 over 5. That's going to be 27 over 5. And DE, that's going to be this one. That's going to be 9 times, and then the sine of C, so that's going to be, that's going to be 4 over 5, which is 36 over 5. So we have this length and this length now. Now we can get AE, because this whole thing is 15, and this is 27 over 5. So we get AE equals 15 minus 27 over 5, 15 minus 27 over 5, which equals 48 over 5. So now we know that this is 48 over 5. The last thing left for us to do is to notice that ABD, this triangle, and AFE, they are similar triangles. And we can know that because if we label this angle as, then this is also going to be a red angle, because ABDF, they are on the same circle, and this is going to be the arc, so those two are going to be equal. And since this is not 90 degrees, that means this much, that's 90 minus that red circle, that's 90 minus the red circle, and this is 90, which means that this is also the red circle. And so those two angles are equal, and this is 90 degrees, this is also 90 degrees. That means that, so that means that ABD and AFE are similar. So ABD and AFE are similar, and that means that their length ratio is also the same. So since BD is 5 over 12, that means FE, that's 5 over 12 times this one. So this gives us that FE, this is equal to 5 over 12 times this one, 48 over 5. 48 over 5, and that's going to be equal to 4. So this is 4, and we got DE from before, so DF, that's going to be DE minus FE. So DF is going to be this minus this, 36 over 5 minus 4, this is going to be equal to 36 minus 20 over 5 equals 16 over 5. And so we have this is M, and this is N. So M equals 16 and N equals 5. M equals 16 and N equals 5. This gives us the sum of 21, and that's our answer. It's B. Number 20, for x between 135 and 180, points P is cosine x, cosine squared x, Q is cotangent x, cotangent squared x, R is sine, sine squared, and S is tangent, tangent squared. And they are the vertices of a trapezoid. What is sine of 2x? Okay, so the only reason that they gave us that range here is for us to determine what sine, cosine, tangent, and cotangent can be. So if it's between 135 and 180, this is between 3 over 4 pi and pi. So the sine is going to be positive, and it's going to be from 0 to root 2. And the cosine, that's going to be negative, and that's going to go from negative root 2 up to negative 1. And the tangent, this is going to go, this is going to be negative, and this is going to go from 0 to 1. And the cotangent is just the tangent, and then it's just the tangent reversed. So it's same sign, it's negative, but it can go from minus 1 to negative infinity. So if we just plot those out, then that's gonna look something like this, right? And by the way, so this graph is y equals x squared, because if you notice, all of those points are in y equals x squared, because always the y is the square of the x value. And so all those points, P, Q, R, S, they will be on here, and now we can plot these points. First has to be between negative 0 and minus 1, so that's going to be like somewhere here. That's going to be our tangent. And cosine, that's going to be from minus 1 to minus root 2. Let's say that's over here. Sine, that's from 0 to root 2. So let's say that it's about here. That's our sine. And cotangent, that is from anywhere from cosine and up. But then since it has to be the vertices of a trapezoid, that means that this and that much has to be parallel. So let's say that just this point is cotangent. And now we know that these two are parallel. So what that gives us is that the rise over 1 is equal for the cotangent and the sine, and the cosine and the tangent. So this gives us that the cotangent and sine are parallel. So this and the cosine tangent are parallel. This gives us that it's sine squared minus cotangent squared over the sine minus cotangent. Sine minus cotangent. I should be like writing x all over here, but I'm just too lazy. So let's just go with this. So this is going to be equal to cosine squared minus tangent squared over cosine minus tangent. And this is just difference of squares. That's just going to give us sine plus cotangent. Sine plus cotangent equals cosine plus tangent. And so rewriting, we have sine x plus cotangent x equals cotangent x equals cosine x plus tangent x. So now if we get rid of this much, then we are going to have this left over. And so from this we can, so now let's just move that over there, move that over there. So we have to do what we can. This gives us sine x minus cosine x equals tangent x minus cotangent x. So this is going to be equal to, so that's equal to sine over cosine minus cosine over sine, which is just equal to sine squared minus cosine squared over sine cosine, like that. So this is going to be equal to sine x minus cosine x. This can be in difference of squares, so if we get rid of that, that's going to be sine x plus cosine x, and that's going to be 1. And so if we move this over, then that's going to be equal to sine x cosine x equals sine x plus cosine x. This is going to give us that if we square both sides, and let's say sine x cosine x, this is a for like simplicity, then we can say that this is a squared. So if we square both sides, then it's going to be a squared equals sine x plus cosine x squared. That's just 1 plus 2a. So that's going to give us that a squared minus 2a minus 1 equals 0. So this gives us that a is equal to 2 minus 2 root 2 over 2. That's going to be 1 minus root 2. And so a is equal to 1 minus root 2, but then we wanted sine of 2x. This is going to be equal to 2 sine x cosine x, and we saw that sine cosine x equals a. This is 2a, which equals 2 times 1 minus root 2. This is 2 minus 2 root 2. And so there's our answer, it's a. Number 21. Consider the set of 30 parabolas defined as follows. All parabolas have as focus the point 0, 0, and the directrix lines have the form y equals ax plus b, with a and b integers such that a is between this value and b is between these values. No 3 of these parabolas have a common point. How many points in the plane are on 2 of these parabolas? Okay, so for those of you who don't know the terms focus and directrix, so basically for every parabola that is defined by 1 point and 1 line, and as you might have guessed, those are the focus and the directrix. So this is called the focus and this is called the directrix. And basically what a parabola is if you grab a point on the parabola and connect these two and connect this line, then this and this has to be equal, right? So it's not a good drawing, so it doesn't look quite true, but yeah, but that's what a parabola is. So that's what a parabola actually is, and so that means that these two must be equal, and that must also be equal, and that, so these are lengths that are altitudes, so this and this is always going to be equal. Same thing for over here, so this is going to be equal, and over there, like that, these three are going to be equal. That's what a parabola is in essence. So this is going to be our focus, and this is going to be our directrix lines. And now, first of all, we have to notice that the parabolas have the same focus. That means that if so same focus at 0, 0. And so this basically means that there is 2 intersection points for everything except if the directrices are parallel and on the same side of the focus, because the focus is 0, 0. So what that means graphically is that if we have a coordinate plane and we have one parabola like that, then whatever ax plus b is, so like whatever the directrices are, this is always going to focus. So if the directrix line is not like that, parallel to this or the same sign, then that's going to either be like this or like this, and so it's always going to intersect at, so like this. something like this, right? So it's always going to intersect at two sides. That's because this has to be the focus. And so, keeping that in mind, we have to see that there are a total of 6 times 5, which is 30 possibilities, right? And this comes from this 6 possibilities for B and 5 possibilities for A. So that's 30. And the parallel and the same sides, right? So this one, and the parallel and same sign, this is going to be like 3 choose 2, that's going to be 3. And so this is when there's no intersection, so we have to subtract this 3 from 30. So that's going to be 30 minus 3 equals 27. 27 pairs of intersection, since each one has 2 intersection points. So the number of points that are on 2 of these parabolas, so that's going to be just 2 times because it's in pairs, and then 30 times 27 over 2. So 30 times 27 over 2, this is going to be just equal to 30 times 27, which is 810, and that's our answer. So this is C. Number 22, let m be greater than 1 and n greater than 1 be integers. Suppose that the product of the solutions for x of this equation is the smallest possible integer. What is m plus n? Okay, so basically we can just make all of those have base 10. So that's going to give us 8, and then 8 times, and then those two are going to be log m, log 10 of m, so that's just log m, under log x, times log x over log n, minus, and then log n of x is just going to be 7 times, and then log x over log n, minus 6, and then log x over log m. And then that's going to be just minus 2013. And so if we just pull out all the log x's, that's going to be 8 over log m log n times log x squared, minus, and then log, so 7 over log n plus 6 over log m of log x. This is going to, and then minus 2013, this equals 0, and this equals 0 as well. Now what we have to actually notice is that the sum of the roots for this, which is just going to be, the roots are going to be the values of log x. So the sum of the values of log x is what is ultimately going to give us the products of x. So the products of the roots of x. And so if we do that, then the sum of these solutions, that is going to be equal to this. That's going to be the denominator, log m log n, and that all under this one, and then minus, so this one becomes plus. So that's going to be 7 over log n plus 6 over log m. And so if we just get those together, that's going to be all over 8, and then 7 log m plus 6 log n. So this is going to be simplifying to 1 over 8 times, and then this thing, which is log m to the 7th power times n to the 6th power. This is log of m7 and 6 all to the 1 over 8th power. But then this is the sum of these solutions, and so that means that the things inside here, those are going to be the products of the solutions of x, right? So these are the products of x. So what that means is that x is product. That is going to be equal to m to the 7 over 8 power times n to the 6 over 8, so it's 3 over 4 power. And so for it to be an integer, for it to be the smallest possible integer, then that means that m must be 2 squared, which is 4, and n equals 2 cubed, which is 8. So this gives us that the m plus n is 4 plus 8, which equals 12. And that's our answer. It's 12. It's A. Number 23, Bernardo chooses a 3-digit positive integer n and writes both its base 5 and base 6 representations on a blackboard. Later, Leroy sees the two numbers Bernardo has written. Treating the two numbers as base 10 integers, he asks them to obtain an integer s. For example, if n equals 749, Bernardo writes the numbers 10444 and 3245, and Leroy obtains the sum s equals 13689. For how many choices of n are the two rightmost digits of s the same as those of 2n? Okay, so we need to stop Leroy getting numbers and adding them for no reason. So our base 5 numbers, right? So we have base 5 and base 6 numbers. So our base 5 numbers, so if we see the maximum last 2 digits, those are going to be 44. And for the base 6 number, then the maximum last 2 digits are going to be 55. And so if we add these together, they sum to 99, So what this basically means that there's no carrying over to the hundredths place. And so that means that we only need to focus on the last two digits of base 5 and base 6 number. If we just set some values for the base 5 and base 6 last two digits, let's just say that the base 5 number, that's going to be a mod 25. Since 25 is 5 squared, that just means that a is the last two digits of base 5. And for base 6, same thing, it's going to be b mod 36. Since 36 is 6 squared, then that means b is the last two digits of n in base 6. So now what we want to do is consider 2n. So for 2n, then we are going to have values of, since a mod 25 is base 5, but then we don't know for 2n, 2n is going to be 2a mod 25, but we don't know if that is greater or less than 25, right? And so we have to separate those configurations, we have to separate those cases. If a is less than 25 over 2, that means 2n is going to be congruent to just 2a mod 25, because 2a, that's going to be less than 25. But if a is greater than or equal to the 25 over 2, that means 2n is going to be congruent to 2a minus 25 mod 25, and that's because 2a is going to be greater than 25. Same thing for b. If b is less than 36 over 2, that's just 18, then that means that 2n is going to be congruent to 2b mod 36, because 2b is less than 36. But if b is greater than or equal to 18, then that means that 2n is going to be congruent to 2b minus 36 mod 36. And that's because 2b is, so 2b itself is greater than 36, so for it to be mod 36, we have to subtract it. And so let's just get these values and take them to our next page. Right, so here we have two possibilities for a and two possibilities for b. That means we have 4 combinations in total for what a and b could be, respectively. And so what we're doing now is we're going to go through all of those 4 cases. So the first is when this and this is true. So it's when, first is when a is less than 12.5, b is less than 18. So that's going to be these two. Then this is going to give us that a plus b must be equal to 2a plus 2b, because we want the two rightmost digits of s the same as those of 2n. And so that means this must hold true. This is only true when a plus b equals 0, therefore a is 0 and b is 0. So that's when just a is 0 and b is 0, that's just one way. The second is when we have a is less than 12.5, but b is greater than 18. This is going to give us that a plus b must equal, and then this is 2a, but then this time it's 2b minus 36. So 2b minus 36, this gives us that a plus b equals 36. A and b can equal 12, 24, or 11 and 25, and so on until it gets to 1 and 35. And this is because we see that a has to stay below 12.5, that's why it's starting from 12 and decreasing. And b has to go over 18, that's just satisfied when we satisfy the conditions for a. And we see that this much is 12 ways, right? So that's 12 ways in total. So that's 12 more ways. And thirdly, it's when a is greater than or equal to 12.5, but b is less than 18. This is going to give us that a plus b is equal to 2a minus 25 plus 2b. And this means that a plus b equals 25. And so for this thing, we have a comma b values of, this is going to be from 13, 12, and then 14, 11, all the way up to just 24, 1. And that is because of a's restriction. A has to be greater than or equal to 12.5. That's why we're starting from 13 and increasing. And so this much, that is 12 ways. So that's 12 more ways, like that. Lastly, when both are greater. So it's when a is greater than or equal to 12.5 and b is greater than or equal to 18. This is going to be when a plus b equals 2a minus 25 plus 2b minus 36. This is going to mean that a plus b equals 25 plus 36. Therefore, this just means that a and b has to be equal to 25 and 36. And this is just 0, 0, because a mod 25 is just, so 25 mod 25 is 0, and 36 mod 36 is 0, so that's just 0, 0. That's just what we did right here, right? So that's just the same way, so that's the same thing, so we don't count that. And so, now summing all of these together, we get 12 plus 1 equals 25, And that's our answer, so it's E. Problem number 24. Let ABC be a triangle where M is the midpoint of AC and CN is the angle bisector of ACB with N on AB. Let X be the intersection of the median BM and the bisector CN. In addition, triangle BXN is equilateral with AC equals 2. What is BX squared? So let's draw a diagram of this. So that's what it's going to be. And we're going to have A, B, C like that. And CN is the angle bisector of ACB, so we're going to have these two equal, and this is going to be N. And M is the midpoint of AC, so we're going to have M, and this is going to be 1 and 1, because it said that AC equals 2. And in actuality, this problem is actually much easier than problem number 23 or problem number 20 like we did before. And that's because because we're dealing with shapes, right? So first thing that we have to notice is that since BXN is equilateral, right? So yeah, I forgot to mention this is X. Right, let's write that over here, right? This is X, right? We know that this is 60 degrees, and therefore that means this angle and this angle, they are equal to 120 degrees, and that means this is also equal to 120 degrees because this is also 60 degrees. Let's just actually write the actual angle. This is 120, this is 120, and this is 120. So yeah, those are the angles, and because of those, we see that this and this angle are the same. So this is similar to this triangle because we see that these two are the same and these two are the same. So we know that this and this triangle is similar. So A and C and BXC. This gives us that A and C and BXC similar. Next, we see that because of this, we see that this and this angle are the same. This is shared by BMC and ABC. So we see that this is and this, they are similar. So next we see that BMC and ABC are similar. Those are going to be this triangle, right? So that's going to be this triangle over here and this full triangle like that. So what this is going to give us is that this to this ratio is equal to this ratio. So 2 to BC, right? So 2 over BC, this is going to be equal to this over this. So BC over 1. This means that BC squared is going to be 2. So BC is equal to root 2, right? So BC is equal to root 2. Then let's write that BC is equal to root 2. So this is going to be root 2. And now let's just set BX, so we want BX squared, so let's just set BX as like A, then this would also be A. And now we can just get CX in the form of A, because we see that CX, root 2 of CX, this is going to be equal to A plus CX. And that is because CX, this is part of BXC, and this much CN is a part of ANC. And we just saw that AC to BC has a ratio of 2 to root 2. So it's root 2 to 1. That means that if CX right here, that's just CX, that means CN, which is for this one, that is root 2 CX. And so root 2 CX, that just means CN equals A plus CX because it's A plus CX like that. So this just gives us that CX equals A over root 2 minus 1. That's just A times root 2 plus 1. So that's just root 2 plus 1a. And finally, we can use the cosine rule, the cosine law on BXC. Because we know that this is 120 degrees, and so we can use the cosine law. And the cosine law tells us that BC squared equals BX squared plus XC squared minus, and then 2 BX CX times cosine 120, cosine of 120. And so this is going to give us that BX is just A, so it's A squared, plus CX is just A root 2 minus 1, so A squared times root 2 plus 1 squared, and then minus 2A times CX, so A squared times root 2 minus 1, root 2 plus 1, and the cosine 120, that just gives minus 1 over 2. So this is just equal to A squared times 1 plus this, which is 3 plus 2 root 2, and then that's just plus root 2 plus 1. This is equal to A squared times 5 plus 3 root 2. That's what BC squared is. And BC squared, that's just root 2 squared, that's 2. So we get that A squared equals 2 over 5 plus 3 root 2. That's from this equation here. And this is just simplifying to 10 minus 6 root 2 over 7. So that's our answer, it's A. Problem number 25. Let G be the set of polynomials of the form PC equals this thing, where C1, C2, all the way to Cn minus 1 are integers, and PC has distinct roots of the form A plus IB with A and B integers. How many polynomials are in G? Okay, so the first thing that we can see is that if B is not 0, then that means since we have all the coefficients are real, that means that A minus IB, so its conjugate, is also a root. This is its conjugate. And the next thing that we have to see is that for PZ, then its product of roots has to be 50, right? Product of roots has to be 50. And this means that PZ can be factored into, if we have A plus IB and A minus IB, then that's going to be Z minus A minus IB and Z minus A plus IB, right? Z minus A plus IB. So this is going to be, so this makes that roots product. So the product of the roots, that's going to be A squared plus B squared. And so since this is part of this, that means that A squared plus B squared has to be a factor of 50. So first of all, A squared plus B squared has to be a factor of 50. This is when B is not 0. But if B is 0, or it can be of the form like Z minus C, right? So that's just going to be a real root of C. That's going to be a real root C. So first, now let's just look at A squared plus B squared and what factors of 50 can be. So if A squared plus B squared, this is equal to 1, or 2, or 5, or 10, or 25, or 50. So if A squared plus B squared equals 1, so if this is 1, then it just means that since B cannot be 0, that means that A comma B is just going to be 0 comma plus or minus 1. So that's going to be just one pair. And for when it's 2, then A comma B, 2 is just 1 square plus 1 square. So this can be plus or minus 1 comma plus or minus 1. So this is going to be 4 in total, so that's going to be 2 pairs. And then for 5 is 1 squared plus 2 squared. So this is going to be, if we just change the order around, plus minus 1, plus minus 2, or plus minus 2, plus minus 1. So that's going to give us 8 in total. That's just 4 pairs. And so same thing for 10, if this is 1 squared plus 3 squared, so this is just 4 pairs. And for 25, this is, this can be 3 squared plus 4 squared, which gives us 4 pairs. Or it can be just 0 squared plus 5 squared. This gives us just one more pair because the 0 has to be at A. So this is going to give us 5 pairs. And for 50, this is going to give us, this is just 1 squared plus 7 squared, or it's 5 squared plus 5 squared. This gives us 4 pairs, but this gives us only 2 pairs. So that's going to be 6 pairs in total. Now, this is not all, right? So that's not all, and we have to consider the parts where C as a real root, this can take 2 values each, right? Two values for 1, 2, 5, 10, 25, and 50, right? So we're just going to add 2 to everything. Plus 2, plus 2, plus 2, plus 2, plus 2, plus 2. And these 2 values are just actually just plus or minus this. So plus minus 1, plus minus 2, plus minus 5, plus minus 10, plus minus 25, and plus minus 50. Just plus minus of those. And so these give us a total of 3. And then this gives us 4. This gives us 4 plus 2, that's 6. This gives us 6. This gives us 7. And this gives us 8. So now we have the numbers 3, 4, 6, 6, 7, and 8. But this is not all, because we have to now, so for the product of all roots to be 50, then that means we have to just multiply some of these things to make 50. So then this can be equal to just 50, or 25 times 2, or it can be just 5 times 10, or it can be just 2 times 2 times 5. So for 50, we can just do 8. For 25 times 2, that's just going to be 7 times 4. And for 5 times 10, that's going to be 6 times 6, because this is 5 and this is 10. And 2 times 2 times 5, sorry, that's not 2 times 2 times 5, that's going to be 2 times 5 times 5. And because this is 50, and so we are going to then take 1 from 4, so just 4, and then choose 2 from 6, because that's just choosing 2 from 5. So this is all going to be equal to 50, that's 8, plus 25 times 2, that's going to be 7 times 4, 28, plus, and then 5 times 10, that's going to be 6 and 6, that's 36, and 2 and 5 and 5, so that's going to be, choose 1 from the 2, so that's 4, and then times 6 choose 2, right? 6 choose 2, which 2 for the 5, right? So that's going to be equal to 132, right? And to this we have to multiply 4, right? And then multiply 2, 2. 132, multiply 2, multiply 2. And the reason for this 2, that's because they're all in pairs, right? So it's 1 pair, 2 pairs, 4 pairs, like that. That's why we multiply 2. And for this one, that's because of x plus 1. This is because of x plus 1. X plus 1 can go either inside or outside, and it doesn't really matter. It doesn't really affect this 50. And so that's just for whether x plus 1 will go in or go out. So in total, this gives us a value of 528. And that is our final answer. Our answer is B. And so that was our journey for the AMC 12B from the year 2013. And thank you for watching.